In this video, I want to talk about the concepts of sensitivity, specificity, and predictive value. And generally, these concepts come up in the context of talking about testing for the presence or absence of a disease. And we'll often make a table to kind of describe the results of that experiment and to summarize it. So we'll put disease on the top generally, so people who do and do not have the disease, and the results of the test on the side, positive and negative. So let's say if we have 1,000 people and let's give 17 of them the disease and have 983 be healthy, and we test everybody of the 17 who do have the disease, 15 test positive, we got a couple false negatives. Of the 983 who are healthy, and the vast majority are going to test negative, but we'll throw in a significant number of false positives there. And then we'll go ahead and calculate the sensitivity and specificity. So we'll start with sensitivity, which is the number of true positives over the number of people with the disease, which in this case we have 15 true positives and a total of 17 people with the disease. And so our sensitivity is going to be 88%. And likewise for the specificity, just call it spec. Okay, so for specificity we have the number of true negatives, just kind of the opposite of sensitivity in some ways, divided by the number of people who are healthy. So we have 780 true negatives, and we have a total of 983 people, 983 who are healthy. So let's go ahead and calculate that. 780 divided by 983 is 79% specificity. And I'm not going to spend a lot of time on just the calculation because you can look that up anywhere. I want to address a couple common misconceptions about these, or a couple things that I struggled with when I was learning these concepts. For one, sensitivity and specificity are not necessarily related to each other. If you have high sensitivity, that doesn't tell you anything about the specificity, and vice versa. They can both be high or low. They don't depend on each other in any way, shape, or form. And the difference between the two is basically sensitivity is telling you how good the test is at picking up cases of the disease. So if you have a test with really, really high sensitivity, that's great. You'll probably catch every instance of the disease, or nearly all of them, but you might get a few false positives in there. Specificity is telling you how good that test is at looking for a particular disease and narrowing in on that one really specific sort of pathology. And so if you have a test that's very specific, you won't get a lot of false positives. In other words, you won't pick up other things that look like the disease but aren't really the disease. But you may get some false negatives. So these numbers are not numbers that you would use after you perform a test. This is another thing that I think is pretty important to emphasize. These numbers describe the quality, I'm going to say, of the test. And they tell you what it's useful for. You might have heard these mnemonics: spin and snout, which basically says that highly specific tests are good for ruling in disease, highly sensitive tests are good for ruling out disease. And that's just based on what I said before. So if you have a sensitive test, you're going to pick up the vast majority of people who do have the disease, because it's very sensitive, very good at picking up every single case of the disease. So if they test negative, you got a pretty good chance that you don't have the disease. You can rule it out. And vice versa. For specific tests, they're very good at picking up just that one particular disease you're looking at and not anything else. So if you get a positive result, you're more likely to rule that disease in. Let's go ahead and talk about predictive values as well. So we'll go ahead and calculate the positive predictive value. So this is kind of similar to sensitivity in that we have the number of true positives on top. But in contrast to sensitivity, we don't take the number of people with the disease, we take all the positive. So the number of people with positive tests on the bottom. And so in that case, we have 15 true positives. And then we have 15 plus 203 is going to be 218 people who test positive. So let's go ahead and calculate that. I think you can already see, yep, it's a pretty small number, about 7%. And then negative predictive value. Is going to be similar to specificity, but not the same. It's the number of true negatives divided by the number of people who have a negative test. So that's going to be all negatives. So in this case, we have 780 true negatives, 782 negatives total. And you can see this is going to be a pretty high percentage. 780 divided by 782, 99.7. 99.7%. So what the predictive values tell you, it's not so much as something inherent to the test as these predictive values tell you how to interpret the test results. How to interpret test results. So what they say is, for instance, let's look at positive predictive value. If you get a positive test, the chance that that's a true positive test is only 7%. On the other hand, if you get a negative test, the chance that it's a true negative is very high. Now, the important thing to remember about these, and I'll put a star next to it, this is a critical concept really, is that these vary with prevalence. And prevalence is just basically how common the disease is. So in this case, prevalence is 17 out of 1,000, or that would be 1.7%. So basically that means this is a rare disease. And kind of makes sense that you would get a low positive predictive value. It basically says no test is perfect, everybody makes mistakes, and so your chances of making a mistake and getting a positive test just by accident are greater than your chances of actually having the disease. And that's why this positive predictive value here is so low at only 7%, despite the test having pretty good sensitivity and specificity. If I were to increase the prevalence arbitrarily, you would see that the positive predictive value would increase pretty dramatically, because then the chances of having the disease would go up compared to the chances of messing up the test, which would hopefully stay about the same. And so I want to compare and contrast these a little bit. Sensitivity and positive predictive value both have the number of true positives on the top. But in sensitivity, we're comparing it to the number of people who actually have the disease. In positive predictive value, we're comparing it to all the number of positive tests. And likewise with specificity, again, we have true negatives on the top, as well as true negatives on the top for negative predictive value. But for specificity, we're comparing it to the number of healthy people. For negative predictive value, we're comparing it to all the negative test results. And so if you like to understand concepts based on patterns, which is something that I do a lot, you might notice that the true value is always on top. So true, 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 whether it's true positives or true negatives. And then sensitivity and specificity, the number on the bottom is going to be the actual state of the individual being tested. Do they have the disease or are they healthy? For predictive value, we're just looking at the total number of positive or negative tests. So hopefully that this video has helped you understand this a little bit better and maybe given you a couple hints as to what these concepts really mean in a way that will help you remember them without memorizing too many mnemonics or formulas.